What's up, guys? Welcome back to another Algebra 2 instruction lesson here with Mr. Gaines as we continue our work with basic sequences and series. Today we are going to focus on a series and partial sums. So let's start with the definition. A series is essentially the sum of all terms in a sequence. So we talked about sequences in previous topics and how they were a list of numbers in a given order. And now if we start to add them together, that's what we call a sum. So we have some notation here. So given a sequence that has A1, A sub 2, A sub 3, all the way to A sub n, this sequence here, the series of the sequence would be A sub 1 plus A sub 2 plus A sub 3, adding those terms all the way together to A sub n. So the notation here with this capital S and what we're going to have a subscript number here is going to tell us how many terms to add together. So in problem number 6, it says given A sub n equals 2n, so here's the general formula, find the value of S sub 4, series sub 4, or the sum of the first 4 terms of the sequence. So what we can do, again, I showed you how to find those general terms on the calculator. We can go ahead and go to the calculator, go to y equals, and put in the general form using x instead of n, and take a look at the table and start at 1. So S sub 4 here means to add together the first 4 terms of the sequence. So the first term, as I look in my calculator, is 2. The second term is 4. The third term is 6. And the fourth term is 8. So 2 plus 4 plus 6 plus 8 gives us 20. So the series of the first 4 terms of our sequence here is 20. Now if we wanted to find S sub 7, this would be S sub 4 plus the next 3 terms as well. So the fifth term, we can check the calculator there, looking at the table, is 10. The sixth term is 12. And the seventh term is 14. Now, you can add all these together in the calculator if you need to, but I'm going to go ahead and realize that the first 4 terms are 20, and the next terms would be 36, and so this would give us a series of 56. So S sub 7, the sum of the first 7 terms is 56, and S sub 4, the sum of the first 20 terms is 4. So you have to be able to find the terms, but from there, it's just adding them together. Now, another way that we can write a series is in what we call summation notation. So summation notation looks like this. So the series of n is equal to the summation notation with this representation. So what we have here in this is we have some different pieces on this summation notation. This down here at the bottom, k equals 1, is called the lower limit. And this is where we begin the series. So in this case, 1, k equals 1, would tell us to start with the first term. N is the upper limit. And this is where we end the series. And then a to the k power, this is called the element. Or this is essentially the formula to find a term. So we'll just call it a formula for right now. So variables may vary here, but what this says is add the first term through the nth term found by this expression. So let's take a look at problem number 7. It says compute each of the following sums. So the summation of, this is written slightly different here. Notice the little bit of a different representation, but our lower limit is 1. Our upper limit is 4. So we are finding the first 4 terms of 3i plus 2. Now, 3i is, don't get confused here, this is not necessarily an imaginary number. I don't necessarily like using the variable I, but this is just a variable. So what this is telling us to do is take the first term, added to the second term, added to the third term, added to the fourth term. And again, we can use the calculator here to help us find these terms. Let's put x in instead of I. And the first term here would be 5. The second term would be 8. The third term would be 11. And the fourth term would be 14. So 5 plus 8 gives us 13, plus 11, 24, plus 14 is 38. So this would be the same as S sub 4. So it's a different way of writing to find a series, which is, again, adding together the terms of the sequence. Let's take a look at another example. Example B here, we need to find from the lower limit of j equals 1 to the upper limit of j equals 5. So I'm finding the first term, adding the second term, adding the third term to the fourth and the fifth. So see if you can pause the video and find the summation of this series. Hopefully you were able to find that value. Let's go ahead and let's put this into the calculator here to help me find my terms. So I'm going to put it in as a fraction, so it gives it to me as fractions. Now maybe you did this as decimals, and you'd want to make sure that your decimal approximation is the same as my decimal approximation. So this would be 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5. Now this is an addition of fractions, and rather than finding all of the common denominators here and adding together the fractions, I'm going to go ahead and do that work in the calculator. You could do this by hand, but it's a little bit quicker here to do it in the calculator. And I'm going to give an exact answer and put this into fraction form. And so this would end up being 137 over 60. So this is the same as finding S5, the first 5 terms of the series. Now, the reason we use summation notation is for examples like C. In C, notice the lower limit. The lower limit is actually 3. So we're not doing the first 6 terms. We're actually going to add together term 3, 4, 5, and 6. So this is telling us we're not starting at the beginning here of the sequence. We're starting at the 3rd term and then adding together up those terms up to the 6th. So let's go ahead and let's find the value of these terms. Let's use the calculator again. So -1 to the x power times x squared. I'm just replacing the k, our variable is k here. I'm replacing it with an x. And I'm going to go ahead and look at the table. And again, I'm starting at the 3rd term. So this is actually -9 plus the 4th term is 16 plus the 5th term is -25 plus the 6th term would be 36. And you may be able to do this mentally, but let's go ahead and make sure we don't make any mistakes here and type this into the graphing calculator. And the summation of the terms would be 18. So when we see that summation notation, we do have to take into consideration what the lower bound is, in this case 3, and what the upper bound is. That tells us where to start in terms of what terms to use and where to finish. And then this sigma, this summation, means that we're going to add them together. So it's a little bit different way of writing a series. Now in problem number 8, it tells us to write the following terms in summation notation. So here, we have to be a little bit creative. So first, we need to identify what's occurring from one term to the next. And so what I can see here is I have some odd terms, 1, 3, 5, 7, 9, and so on and so forth. So if I look at a way to represent this, let's let this be A1, let's be A2, A3, A4, and A5. Now I need to come up with a way to do some kind of arithmetic operation to the numbers 1, 2, 3, 4, and 5 to get those numbers shown above. And you may remember this back from Algebra 1, but the odd numbers can be found by taking 2n minus 1. Remember, 2 times anything would give you an even number. And then if you subtract that by 1, that gives you an odd number. So this is going to be a summation of the element 2n minus 1. Now, where do we start? We let n be our variable, and we started at a equals, or a sub 1, so we start at n equals 1, and we end at 5, the fifth term. So this would be the summation notation for what we see above. The element 2n minus 1 gives us the terms if I substitute in 1, 2, 3, 4, and 5. And if I start at 1 and end at 5, that gives me each of the 5 terms that are being added together. Now again, that's not the only way to represent this information, but it gives you one summation to find the series. Let's take a look at B. B gives us a little bit of a different. Now, a couple things we may notice is that this continues with, this has a dot, 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 like a continuation here. So this is going to be an infinite summation. It's going to be a sequence that goes on forever. It's a sequence that is not finite, it's infinite. So we're going to have that to take into consideration. But for right now, let's figure out what happens here. So what we can see is we have a 6, a 9, a 12. So these look like, those are all multiples of 3, right? So let's make this easy. Let's make the element 3n. Now, what the problem with this would be is 3 to the n. If I start with a of 1, 3 times 1 is not 6. 3 times 1 is 3. So I can make a little change here and make this pretty easy by making this a sub 2, and then a sub 3, and then a sub 4. So I'm actually changing the term that I start with. 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. This matches the sequence that we have above. But now with my summation notation, I am going to start with an n value, but I'm going to start with n equals 2. So we started with the second term of multiples of 3. And then this one goes on forever. So we're going to use the infinity symbol. So our summation here would be from 2 to infinity of the sequence 3 times n. And so here we have some examples of series, which are addition or the summation of sequences, and how we can write it in some different notation. This is a good place to stop. As always, thank you guys for tuning in. I'll see you soon.